Okay, in this example, I'm going to convert a decimal number that has a decimal point into a different base. All right, in this case, we're going to do base 8. All right, but really the process is the same no matter what base you use. You just use, you know, the radix number to do the calculations. All right, so we're going to do 112.7. And what we do is we break this up into two parts. We're going to take care of the integer part first, and then we're going to worry about the fractional part second. All right, so for the integer part, what I'm going to do is I'm going to start with our number, and then we divide by 8. And so I just use a simple 4-function calculator to do this step. So 112 divided by 8 is 14, and there's no remainder. So we write that down, and then I go to the next step. 14 divided by 8 is 1, and I just wanted to point out that when you put that into your calculator, you get 1.75, and if you just want a mindless way to find the remainder, you take the fractional part of that number, okay, the fractional part, and you multiply that by 8 to get the remainder. Okay, so from there, you can read off the conversion. You start at the, basically what we're doing is pushing powers of 8 into the original number. So you start at the bottom and you move up. So 106. All right, so that takes care of the integer part. All right, so next we need to worry about the fractional part. And so with the fractional part, I'm going to start with the 0.7. All right, and so basically that's my starting point. Let me draw a line here to keep that clear. Okay, that's my starting point. And instead of dividing, because it's the fractional part and it's negative powers of 8, we're going to end up undoing the negative powers by multiplying by 8. All right, so that's equivalent to like pushing negative powers of 8 into the fractional part. Okay, so take 0.7 and you multiply by 8 and you get 5.6. Okay, and the critical part here is you take the fractional part again, 0.6, and you multiply by 8 and you get 4.8. Okay, is the next step. All right, so we keep going. All right, and 0.8 times 8 gives me the 6.4. 0.4 times 8 gives me 3.2. 0.2 times 8 gives me 1.6. 0.6 times 8 is 4.8, and we notice I've seen that before, and so you're going to end up repeating that sequence because 0.8 times 8 is 6.4, and you would continue on. So basically, at that point, we know that rational numbers can have a repeating decimal pattern. All right, and so 0.7 base 10 ends up with a repeating fractional part. All right, so we copy that number over, and this would be 0.54631, and the 4631 repeats. All right, so there's a quick example on base conversion where we're going from decimal to a new base.